talk is about vector cartography and also problem localization, but we're going to talk about it in English. So I'll try to talk more slowly. Okay, so hi, I'm Brandon, talking about this track is OpenStreetMap. We're specifically going to talk about base maps. So what is a base map? I'm just going to try to clarify. It's usually the map in the background of an application. So if anyone has seen the mask map or just OpenStreetMap, it's a map that's usually behind the data that you're showing. And its goals are usually to add some location context and also to represent the physical and cultural world accurately. And it's quite often a hosted tiled web service that has national or even global coverage. And there's a few clarifying points I'm going to make about what base maps are. The first one is that a base map is multi-resolution. That means it has different zoom levels. So the thing on the left is not really a base map. It's just the data of type A opening QGIS. But if you zoom out, it shows the same data. So the important point for base maps is that they have automated generalization. And that's a fancy way of saying when you zoom out of the map, there's less detail. So there's some program that knows how to remove the detail from the map at each level. So the second feature of base maps is that they have useful labels in one or more languages or scripts. So the thing on the left is a base map, but it has some evidence of manual label placement. So this is when I was just running in the park by the river. There's some bridges, and you can see that the label for the bridge is on the left side. So that's probably someone in Photoshop or in Illustrator that designed the map in that way. And for the base maps we're talking about here, they all have automated label placement. So on the right is OpenStreetMap, the Carto layer. And you can see that in general, when there's a road, there's an automated placement of the name on the road. And base map data, there's lots of it around. Everyone knows Google Maps, Apple Maps, Esri Maps. But today's focus is on base maps for the web, so in a browser, specifically for Taiwan. And those that are created with OpenStreetMap, which is available under the Open Database license. So other base maps, they might not have open source data. There also is non-OSM data sets for Taiwan. There's some that are published by the government, but they might not have enough data to be a complete base map. They might not be open source, or the license might not be compatible with the OSM license. An example is if you go to this repo, github.com/github/gpustd, there is a really high quality building data set for Taipei. However, that data set is available under a license that's not compatible with the OSM. So we can't really use this data. We're only going to focus on OpenStreetMap. So why do I care about this? About me, very quickly, I studied computer science. I've been working with OSM since 2012 when I wanted to build a bike map of where I was living based on how steep each road was. In about 2014, I added all the building heights to San Francisco. And since then, I've been working mainly as a data and cartography sort of consultant for companies, including Stinin and also Hot OSM, which is an NGO that does humanitarian work. I maintain a lot of open source tools around OSM. I don't do a lot of editing. I mainly build sort of infrastructure. So you can check out my GitHub. I currently also run 2 commercial products based on OSM. One's called CADmapper, and the other one I'm going to talk about a little bit more, which is new, called Photomaps. In terms of tools, I generally use C++, Python, some Go, Rust, and I'm interested in databases and graphics. So that's some background on why I like base maps or why I care. And we're going to talk about first raster tiles. We've heard a bit about those today, such as the ones online by Stinin, Wikipedia maps, and the main OSM style, which is called OSM Carto. These are all raster-based, so they have an image at a fixed size. that cannot be rescaled losslessly. So if you zoom in real quickly, it'll get blurry because it's just like a PNG or JPEG image. And these all happen to use the MapMake free software rasterizer to generate the images on the server. Vector tiles, one slide intro. You send only the data instead of an image in that tiled format. It's an open spec based on protocol buffers. And the ecosystem is largely made by a company called Mapbox. They have a lot of really great sort of open source tooling around vector tiles. There's other OSM providers. There's the ecosystem around a project called Open Map Tiles, one called Tiles, and also Protomaps, which is the project I'm working on now. So here's a very broad rundown of these pros and cons, raster versus vector. Raster is simple. It has a decade of tooling behind it, but there can be lots of tiles. You can't customize it once it's been rendered, and it can be blurry. Vector tiles can be completely interactive, but there is a smaller open source ecosystem. And what I want to talk about in particular today is what is specific to Taiwan, or CJK as in Chinese, Japanese, and Korean languages, that might be interesting about vector tiles. So I think a lot of people have the impression that the vector is the future and everything should just be vector. So I'm going to show you sort of, this is like Mapbox Studio, which is the Mapbox commercial product. And what you'll notice is that, if you can see closely, if you try to make the characters, in this case Chinese characters, very big, they will all become very, very round. I don't know if you noticed this. So this font that is using, I think is just like it's called like a Haiti font, which is like a sans serif font. But it will always become round when you make it big. So here's a closer look. And why is this? Because it's not very pleasing to the eye in that, like, even if you choose a sort of Haiti font that has sharp corners, it will always become this way. So why is this? So in particular, for the Mapbox GL library, it uses a technique called sign distance fields. And the reason behind this is that a hardware accelerated API only knows about two things. It knows about textures and it knows about triangles. So the way they render text is to generate a bitmap called a sign distance field, where each pixel stores the distance to the edge of the glyph. That's stored as a texture on the GPU, and it's sampled in a shader in order to render text. And this is a really good technique because it means that text can be scaled infinitely, and it can be done very, very fast. And it does not need to touch the CPU at all. It can also be rotated. But the big drawback is that visually, it will always be round. And this is the worst case for traditional Chinese characters because they have lots of strokes internally. It doesn't affect simplified Chinese much. So I really like the example of jiayi, which has lots and lots of strokes inside. That you can think about, there's so many place names that have these complex characters, and this renderer will kind of like always render them this way. And there is some strategies to improve this. You can use multi-channel sign distance fields, which store a different sign distance in each channel and then average them. There is another renderer for vector tiles called HarpGL, and it does use these. The other downside with these renderers for Chinese characters is it needs to download all of these distance fields over the network. And this can get really slow when you're browsing an area that has completely Chinese place names, because it will need to fetch a range of Unicode glyphs each time you pan the map around. So this is really not ideal for CJK characters. Oh, and there is a new feature in Mapbox GL called local ideographs, and that will actually avoid the network, but you're limited to local fonts only. And maybe we should just accept this because, as you might know, technology constraints have always influenced the appearance of text. So on the right is what's called a songpi, fonts or a script style, and the vertical strokes are always thicker than the horizontal strokes. And that's because back in the Song Dynasty, these were printed using woodblock. And wood has a grain, and the grain would always be horizontal and not vertical. So it was much easier to draw a thin stroke horizontally than vertically. So this is 1,000 years ago. But 1,000 years later, our tools look more like this on the left. They're GPUs, and maybe the design of our tools now are going to influence how text looks. But I don't think that's very satisfying from a design perspective, to always have one style of rounded font. So there is some strategies. So I'm working on extending a project called Tangram.js. It is an MIT licensed WebGL vector tile renderer created by Mapsen, now a Linux Foundation project. And it does fixed size rasterization via canvas directly to a texture and then displays that. So you lose the ability to scale text infinitely, but it means that CJK text in particular is as high quality as is possible in the browser. And this is one of the features of this new Photomap stack I'm designing, that it supports Tangram.js. You can find the source code, it's all open source on GitHub. So you can see on the right style is sort of different map styles rendered with Tangram. You can blow up the label quite big and it still looks sharp. The second problem I'm going to talk about is what I call stinky tofu, which is that even in Tangram, you will find some places in Taiwan that show you tofu like this, this character, and why is that? It seems like something's broken. And it turns out this is a place in Tainan that, if you look at it on OSM Carto, it will be on the left. It will be the grass radical on top of the king character. I believe it's pronounced Wang Lai Zai. And so if you ask someone, well, like a lot of people will see this and say, I don't know what that is. Like I don't know how to say, like, if you recognize this character, raise your hand. Yeah, but I was also, curious about this. It's not in the dictionary. You can't even type it in your browser. And I went to Google and I looked on the left, and it's different. It's the normal, like, king no Wang. Apple is the same thing. And if you even search for it on Google with the more common character, you will find real estate listings that have it under this Wang Lai Zai. So it thinks it's a real place. But then, interestingly, if you choose a different character, which is tool, which is the grass on top of the earth, there's also results for tool Zai. So it seems like the internet can't decide which one of these characters is the right one. And it turns out that OSM is right. I think it was Dennis that might have added this, and that this is a historical place name, well, that's still used today. It is indeed that character. It's a very rare one. It's not in the basic set of Unicode characters, but it does exist. But it might not be in the font that you're using to render the map. And that's an issue with vector maps, because since all the text is being rendered on the client, if your font doesn't have the character, then it doesn't work. So you can see that even in the signage in this place, they have the correct character. You can see the meaning and where it comes from. This is a historical map from 100 years ago that has that character. This is not a very common issue. I analyzed the entire country, and I think there's maybe a few dozen characters like this, but it is interesting. And that brings me to the next topic, which is similarly just some characters, but it turns out that who has heard of unified HANA ideographs before? So the issue here is that OSM data is in UTF-8. And the way, like when they were designing Unicode, they combined some characters from different locales. And the most common example of this in OpenStreetMap is this character Dao. So in Taiwan, the character Dao is written with 13 strokes, but in the PRC it's written with 12 strokes. And anywhere you go in Taiwan, it will use what's called simplified Chinese locale character for this. And because OSM card uses mapnik, which uses heart fuzz for text shaping, it can support this if it has data about the locale you're using. But as is, it will just default everything to simplified Chinese versions. This can be solved in raster tiles with a font that is specific to either traditional or simplified Chinese. In vector tiles, it's a little bit better. So you can see here's some common characters in place names, and you can see how they vary very slightly. And the browser does support this kind of localization, and it supports this by using the language attribute on the DOM. However, the canvas needs to be attached to the DOM for that to work, I discovered. So Tangram can't support this out of the box. But what you can do is you can choose a font to render with based on the browser. So like Apple has this built-in PC font that will have all versions of that Unicode code point in the traditional Chinese version. So it's not a global solution. It won't work if you have more than one locale on one map and you need to have some of them be some way and the other is a different way. But you can see that in the bottom right, I'm using Tangram, and it uses the 13-stroke version, which matches the one that is used on street signs. But now that we're talking about labels, there's actually a lot of very interesting things about Chinese map labels. There's an exhibition that the city, I think, archives is putting on, and here's a historical map from 100 years ago, and you'll notice that all of the labels are vertical. They go from top to the bottom instead of left to right. And that's very common in so-called CJK maps historically. And that's also true now, because there's no reason why you can't write the characters from top to bottom. It's not like English where it's hard to read. It's very common, and it's almost the default for if you need to label a road that is vertical to label the characters from top to bottom. And Mapbox.gl actually supports this. But it's something that is not supported yet in either Tangram or mapnik. Yeah, I'm pretty sure mapnik does not have this yet. And what you might notice is there's multi-script labels. So there is both English and Chinese in the same label. And this is very common. There might even be triple script labels where a lot of tourist map in Taipei, they will have English and Japanese and Chinese all on the same map. And this is an exciting opportunity for vector tiles because you can choose what language labels you want to put on the map on the client. So the OSM community in Taiwan has done a lot of work to add multilingual labels, specifically for Taiwanese or Taigi, and also for indigenous languages and Hakka. And this is a really good match for an open source project because apps like Google and Apple are probably not interested in showing these languages, even though there's a lot of people that are interested in them. And I added a link to Dennis's talk from last year, where he talks in more detail about adding this data to OSM. So you can just see a quick overview of each of these tags and how prevalent they are in Taiwan. So there's Hakka, and then here is Amis. So all this data already exists. It's just a question of how do we show it in maps. So not every vector tile API has every single name tag. This is something that explicitly designed like this new service called PhotoMaps to do. It will not sort of, it will retain all tags. Some vector tile services will remove less used names. But if you have all the tags in OSM, it's possible to render a map with as many language labels as you want. And you can even do things like, you can build an interactive editor that goes to iTidy, which is a website that helps you learn how to pronounce Taiwanese words. So you can link directly to it from the map as a sort of language learning tool. You can even use this as a specific editing UI. So I have in gray all the ones that don't have a name NAN tag yet. So you can sort of use this interface as a way to even edit or have a link to where to add data. So exposing multilingual data is a very strong feature of vector tiles. But there is some caveats, which is that if we add, or if we're able to show multilingual data, then many more people are interested. OSM has verifiability as a guideline, and it might be quite hard for a language to have verifiable data, which multiple people can agree on, especially if the government in the past has not supported that language. Like for example, in Taipei, there is Wanhua district, and then in some places on the sign they say Mongjia, but I think it's pretty unlikely that you want to label the map saying Mongjia. And there is place name databases, but usually they have not had a license compatible with the ODBL. Cool, so I'm going to move on to the last related topic, which is about if you're in Taiwan and you don't speak Chinese perfectly. Most people now, they know pinyin, which is which has become the international standard, for romanizing like Mandarin. So there's many map users who might be illiterate in pinyin but not Hanzi. And if they want to find a place on the map, or they want to look at a map or read place names, if they don't know the characters, they might not be able to do that. Also, pinyin in signage usually does not have tone marks. So if you like it has like Xinbei, like they usually do not have the diacritics for that place name. And it's also, especially outside of Taipei, the romanization is not consistent. So OSM does have a tag to store this data, but it would be a lot of work for mappers to go in and add pinyin to every single object. And pinyin is also quite hard for computers to use because you need to use a lookup table to parse it. It's a non-regular language. So a small demo I've been working on is if you want to build what's called a Zhuingwen map. So this is a completely automated system that it uses Mengdian, which is the Ministry of Education dictionary that there's lots of apps built on it by GovZero. So you can sort of, it will automatically transcribe characters to Zhuyin, and this actually also works for pinyin as well. And yeah, so it works globally. Like, so in the case there is a Chinese name for a place that is in Brazil, it will also be able to transcribe that. And you can find this code to support this on GitHub. It's a new library that is called Hanzi to reading. And the main issue is that there's what's called multiple reading errors, or 4音字. So in those cases, you need a dictionary to be able to look up, how a sequence of characters can be transcribed. So I'm working on this new sort of dictionary format that supports multiple phonetic systems. You can see if I want to encode this syllable kyang, then you can see like it's 10, 1, 11, 1, 0, that maps to binary. But the idea is that you can use this to transcribe. It's very much a work in progress, but even things like Ludiku, which is the hiking maps. I think there was a GitHub issue where they discovered that if you buy a Garmin device outside of Asia, it will not support Unicode. It only supports the Latin code page. So in order to make these maps usable on those devices, you need to convert all the names to a Latin script. And that's a really good match for that's a good match for turning all of these names to pinyin, as well as if you are someone visiting Taiwan that wants to go hiking, but you can't read the characters, then this is much more accessible. And there's still a lot of wrong transcriptions in the system that I'm working on, but there is one issue, which is that this dictionary Mengdian is under a CC by ND license. And what ND means is that you're not able to make a derivative work. And specifically, the ODBL is not compatible with a CC by ND dataset. But since in order to do a lot of these applications that use pinyin, you need to have a dictionary, and that almost certainly creates a derivative work. There is alternative data sets like CC, CDICT, but it is very focused on what's called Putonghua or simplified Chinese. So if you have a word like here we call it 垃圾, but in the dictionary it will be 垃圾. So for Taiwan place names, it's ideal to have a dictionary that is more localized. But right now there's this licensing issue that it really limits how much a software developer can do with it. If we think about what applications we can build even build things like phonetic geocoders. So if I look up the street name Zhenguo, then ideally I should be able to enter things like mofo and get that result. Or I can enter pinyin and it will find that result for me on the map. And this will be really useful for a lot of people. But it's would all be made possible in open source if these dictionaries also have a compatible license. So second to last slide. Okay, so just as a summary of everything I've talked about, vector map tiles are ideal for multi-script, multi-language labels. If you need high-quality CJK rendering in WebGL, and you're limited to local fonts only, you should check out Tangram. If you have custom CJK fonts, raster tiles are still a good solution, and we should work more on making CJK work well in Mapnik with things like vertical rendering support. And these transcribe maps I've been talking about might need some kind of license change in Mengdian. And to conclude, what we're going to do is build the feature of CJK map rendering, make maps a language tool, a learning resource in Taiwan, and do that all with OpenStreetMap. And if you want to contact me to hear more, or you are interested in contributing, you can find me at brandon@protomaps.com. Twitter, GitHub is always Biden, and I'm also on the GovZero Slack. Great, thank you.
开放一个问题，有没有要发问的？
好像还有3分钟了。
就快到了。
OK。
有问题。
OK。
So with all these licensing issues, is it possible that you can reach out to talk to these organizations to get a more compatible license, or is there a reason that they are incompatible?
From my understanding, for the Ministry of Education dictionary in particular, it was previously under a non-commercial license, and they changed it once a few years ago, and that enabled a lot of sort of mobile applications that are paid to use that dictionary. So if they've changed it once, I think it's possible they might change it again, especially if only the pronunciation part, if only the mofo is CC by, the meaning part of the dictionary can still be CC by ND. I think that's fine. But yeah, this would need someone in the government to be able to change that.
好，那我们就谢谢 Brandon 带给我们的精彩的演讲。我们等等下一个议程是1:05会开始，然后是。